again. So the hardest question for Aspire was how we should call the product. So how would you call it if you couldn't use Aspire name?
Try hard.
Okay, I think you won the t-shirt. Thank you very much.
Are we going directly to the no pause? Everybody hardcore? All right, hardcore.
Do you have an USB?
I don't need it. I'm gonna do like 2 slides and then switch to code. But I'm gonna use this just for the red dot. If that's,
Okay, absolutely. I will leave it here and take it after you finish.
like this, yeah. Okay. Thank you.
You're welcome.
All right. Wow. So we're really doing 2 hours straight of hardcore.NET talk. I'll try to go quickly so as not to keep you guys too late. I hope it doesn't run over. I hope you're also okay if it does run over for a few minutes and it's not like
perfectly
good. That's what I want to hear in general. But I will definitely let me even put a timer so that.
Can we use mic to record?
Of course. Thanks. Just put it on.
Yeah.
Okay. And I will even put a clock to make sure that I'm aware. So, hi everybody. I'm actually talking in English because I don't know Polish, unlike Adam, who for some reason cannot give a thing in Polish. No, I'm just kidding. Nobody knows how to talk about this stuff in any language that is not English in general. But I really don't know Polish. I'll jump. We're going to go very quickly into code. That's going to be the main thing. Just a few slides before about myself. So, my name is Shay Rojansky. I'm an engineer in we call ourselves the .NET data team. So the main thing is EF, but I also own system data at the very lower level. So the part of the BCL that's for talking to databases that do SQL and all that stuff. I also own or one of the maintainers of NPG SQL, which Adam actually mentioned. So the Postgres driver and also the EF core provider for Postgres. So basically, if you're doing Postgres on .NET, you're very likely going through my stuff, let's say. But the main thing that happens in my team is EF. So most of my day is spent doing entity framework and so on. I'm also a perf guy a little bit, so this is going to be a perf talk, but a different kind of perf talk, for example, from what Adam usually does. You will see it's a different kind of perf. We're not going to be profiling and benchmarking. We are going to be benchmarking actually, but we're not going to be profiling runtime performance in the usual way. We're going to talk about another aspect. I'm also a Linux guy through and through. I've always been one, which is kind of embarrassing because I'm standing in front of you with a thing here with a different kind of logo. This is actually a new computer, so it's going to be super fast, unlike Adam's. But on the other hand, I have no idea how the keyboard works because it's a Mac. So all the keys are kind of switched around. There's going to be a lot of crap going on. I came here from Berlin today. So really a few quick words in case people don't know. There's the how many know Tech and Power here? Raise your hands. Okay, not that many. I'll say just a quick word about it. This is a standardized set of benchmarks, mainly for web applications backed by a database, most of the benchmarks and so on. The idea here is it's standardized. This is not a Microsoft thing. Like almost all the major platforms, languages, databases have entries on this. You implement the same set of 6 or 7, I don't remember anymore, standardized scenarios, and you see how it goes. There's leaderboards once a year, or I don't know anymore. They do like an official round and they publish it. .NET is now in the last one, 16. We used to be even in the top 10, by the way, for the Fortunes one. There are other benchmarks where we're better, others where we're worse. This has been a very important tool in general for for the .NET team and the ASP.NET team to optimize and to track performance, also to avoid regressions and so on internally. So it's a very important tool. EF itself is usually not a component that we usually talk about that often in terms of performance, which is something I'm trying to change as well. In EF Core 6, by the way, I'm going to say EF6 a lot in this presentation. The meaning is EF Core 6, not the old EF6. I'm just to make sure there will be no old EF in this talk at all. So in EF Core 6, we did a big push on runtime performance, which is the more classical kind of optimization, where you profile and see where reduce allocations, optimize hot code paths, and so on. That's great. It even so you can see there we had some nice improvements. There's also Dapper, which, by the way, how many people here know, how many people here use EF? Sorry, I should have started in the very beginning. Okay, quite a lot. How many have used Dapper here? Good. I'm talking to a crowd who really knows what I'm talking about. That's always good to know. So in EF Core 6, we actually got to, that was kind of an unofficial goal to try to match Dapper just as a sort of inspiration. And we kind of did it. So Dapper, EF Core, if you use it in a very specific optimized way, will match Dapper performance. But of course, if you just use, you go and do the what's new with tracking queries and you know, let's say the default kind of thing, you will not get Dapper performance at all. I'm just making sure, because it's also not an apples to apples comparison. Dapper just sends your SQL. EF does tracking for the stuff that it loads. That's not the same thing, so you can't really compare it. But it's still quite interesting to see that something like EF, which is a link you know, provider, that's a very different beast. It's doing the SQL generation for you and materializer and everything. We can still get very good performance out of it. That was basically the idea. If you are interested in the sort of high perf usage of EF, then you should definitely take a look at the docs. I spent a lot of time working on them at some point. There's also some pretty exciting stuff coming in .NET in the 9. It's related to work on native AOT, but that's not my talk today. That's only to leave you in suspense a little bit. Okay, so I talked about optimizations, the runtime sort of optimizations, and for querying. In EF Core 7, there was a big push for update optimizations. And here we're no longer in this sort of optimization where you profile and reduce allocations. It's a very different kind of thing. So I actually, one of my messages for you is to always, if you obsess about perf, obsess about the right thing. That's very, very important. People, like, the things start slow, so, you know, they start profiling, they start looking at allocations and so on. That's not always going to be the right thing to do. So this is part of the thing that I'm trying to show in this talk. And in addition, it's very much focused on updates. One last word before we dive into code. That's it. That's my last slide. Now we're going into the actual meat of it. Most of the work was done for EF Core 7, so this is not new in EF Core 8 kind of talk, but I keep encountering people who are not aware of like the new APIs introduced and also the optimization. So I think it's really valuable to, and also EF Core 8 is when this became LTS, right? So a lot of people are only now kind of switching from 6 to 8, so it makes sense. I think it does make sense, and so on. That's it. I'm done with the blah, blah, blah. And now we can switch to code. This is big enough, right? Should be fine. Even in the back, everybody's seeing it. Perfect. Okay, very good. Just a quick reminder, I know everybody here almost has used EF, but just as a very quick reminder what it looks like, this is a hello world kind of program for updates. So we have, you know, we drop and create a database every time. Again, every time I run this, we will drop and recreate a database. The way EF works is we have something called a blog, which is mapped to the database. We add a blog to the database that has the name my blog. At this point, this is important. At this point, nothing has actually happened. Add does not add anything to the database. It adds something to the change tracker. So EF now knows about it, tracks it, and when you do save changes, that is when things get persisted to the database. That's why here we have an async API, whereas add, of course, is not really async. That's also a complicated thing, but I'm not going to talk about it anymore. Here we have a run-of-the-mill DB context. That's the thing you have to do when you do EF. That's basically the starting point. We have blogs, which represents our blogs table in the database. We have some configuration. I'm running against SQL Server, but a lot of this is actually relevant also for Postgres. Again, I'm much more a Postgres guy than a SQL Server guy, I'm just saying, but this is going to be on Postgres. We've also configured some logging events, and crucially, we're especially going to pay attention to transactions, because that's going to be a big part of what I'm talking about. And that's about it. This I'm going to kill right away because it's coming later. And the blog itself, our model is super simple. We have, this is my universal model. We have blogs which have an ID, a name, and a rating, and they also have a one-to-many relationship to posts. And posts have like a title and a reference back. It doesn't matter. All this is not important. That's our basic model that we're going to be using. So let's run this and see what happens. Is it actually working? Yes, now it is. But we are running the wrong one. Okay, yeah, what I also should say before we start is I have the exact same program CS reference from 2 projects, one with EF Core 6 and one with 8, so that we can do the code changes and see exactly what happens across the 2. And that's a nice way to kind of see the improvements. So now we're running EF Core 6. All right, so finally we get to dive into code. And I've got my red dot. So the first thing that you see here is the insert. So this is the save changes. We had our tracked blog. We have our insert here with the blog's name and rating. Then that's clear, right? Anybody knows this. But then we have something else, which is select ID from blogs. So we have two things happening, which maybe is a tiny bit unexpected. It shouldn't be. By convention, if you have an integer ID, EF will configure it as a database generated ID. In SQL Server, this is called an identity column. That means the database is responsible for always incrementing it so that every block will have its own unique ID, of course. This is all basic database stuff, which I'm assuming everybody knows. The thing with EF, because it's based on change tracking and so on, EF always wants to get back all the database generated fields, specifically the ID, because you might continue to do something else with that block, right? And if you now, after what we did, you change something and you do save changes again, then EF will go and update that block, and in order to do that, it needs the ID that was generated in the insert, right? So EF core basically needs to always know everything about the thing, and when we inserted it, of course, we didn't insert the ID because it's database generated, but then EF needs to get it back. And the way we get it back is we do select ID from blogs. Okay, that's a pattern that I'll refer to as insert plus select. It might already be a bit weird for some of you. There is an easier way to get back your database generated things. I'll talk about it. Don't worry. There's a good story here. But the other thing that I wanted to show, and that's the thing that everybody overlooks, is that right before this thing we have a begin transaction, and afterwards we have a commit transaction, right? Obviously, save changes with EF is transactional. If you have an exception somewhere in the middle, it must be atomic, and so this has to be wrapped in a transaction. So I'm mentioning this. The important thing is when you look at your logs, this is quite important. This actually represents a round trip to your database, and this represents a round trip to the database. And these two statements, they're two statements, but they're actually batched. At the very least here, we're using a single round trip. So we do have 3 round trips in order to insert that single row, which is kind of, can we maybe do better, right? That's already a sort of a question. Okay, so let's run this with EF Core 8 now and see what happens there. So the first thing that you see is something has changed here. Instead of having an insert plus select, we have a pattern which, again, if you're seasoned database programmers, if you're really used to it, then you were already asking, why are we not doing this? Why are we doing insert and then select to get back the ID? When you have a perfectly nice clause called output inserted. Okay, I will come back to why it was done that way. There's a very good reason. But in any case, EF Core 7 or 8, if you start using it, you see you have only one thing here. But that's not the exciting thing about it. I checked and so on. The actual insert plus select, again, they're batched. It's a single round trip. The actual overhead of that select is marginal. It's not a big deal. This is not how we win major perf, but it's still better and it's nicer. And it connects to another optimization, which I'm going to talk about. But the more important thing is that we no longer have a transaction wrapping this around. So this committed transaction is from the index creation. It's DDL from the database creation. We don't care. But this statement is no longer wrapped by a transaction. So what's going on? Is this now not transactional? What happens if there's an exception and so on? So the answer is simple. The best the best and sometimes the most powerful optimization things are the stupidest. It's really amazing how it works this way. When you do a single, what I'm going to say is tricky, but I'm going to say it anyway. When you do a single SQL command, especially an update or whatever, it's implicitly already transactional. So there's already a guarantee that as the database is, for example, if you do an update and it's modifying the rows, it's going through the table, if at some point there's some sort of exception for any reason, the database will not be left in an inconsistent state regardless of whether you have an explicit transaction or not. If this is how things work, then it would just be chaos. It would be impossible to do anything, and you would have to always do things in explicit transactions. So for single statements, we don't need to do this. So this optimization, as I said, entirely stupid, is for EF Core to simply detect that there's only one statement that's going to happen, and in that case, to avoid doing an explicit transaction, and we just want 2 round trips. We reduced it to a single round trip, which is what you would expect, right? This is also connected to, remember that I just said we had insert plus select. Now that's already 2 statements. So in fact, the interesting thing about using the outputting is not so much using the outputting, it's the fact that we reduce the 2 statements into 1. Now, in fact, this is again tricky. The specific insert plus select might have also worked without an explicit transaction and still be okay, maybe. But I don't want to go into the really nitty-gritty details, like databases can be quite complicated. The point is that coalescing these 2 things, these 2 SQL commands into 1, also unlocks a very simple way of saying, hey, now there's just a single thing here, let's not do an explicit transaction and pay with 2 round trips. And now I'm going to put my general hat, because this is actually not just about databases. This is round trips for me are my favorite kind of thing. Round trips are the best way to talk about there may be the most important thing happening perf-wise in your application, especially today. So, once upon a time, we were all on premises. You had your database server in the same rack as your application server, high-speed networking, low latency. Nobody cares about round trips. Applications were written this way. They were very chatty. They were going back and forth all the time, and nobody cared. Then the boss comes at some point. I'm guessing everybody knows this kind of story, right? This is like a big classic. Somebody comes and says, we have to move to the cloud. You try to take it and put it in the cloud as is. The whole thing just doesn't work at all. Why? Because in the cloud, you start to have different kinds of latencies. You're not right next to your database server. Latency starts to have a real impact on your application. If you engineered it in a very chatty way, you're doing round trips all the time, that's really screwed up. That's not going to work for you. Really, that's a super important thing. So round trips are, it's also an optimization that gets, you can't measure it because it's only going to depend on your actual, network conditions. I did some games with my shitty Wi-Fi network at home, and I saw, I don't know, with this thing I wrote to tell you about it. It went down from 8.4 milliseconds at some point to 4.5 milliseconds over my crappy Wi-Fi. So we're talking about, possibly 100% kind of improvement, because you're reducing network round trips. And network round trips, basically your application is sitting there, it's doing nothing, while a packet is going, to the server. The server is doing something, and then the packet is being sent back. It's horrible. It's the stupidest thing you could do, is to just sit and do this three times, right? This is like super, super bad. All right. I hope that message kind of made it through. Just for the super internal kind of funny stuff, in the database driver, now we're a layer below in NPG SQL, the raw low-level driver, which just executes SQL. When you do a begin transaction, it doesn't actually do anything either. It will actually flip some bit in its internal state, and the next time you actually execute something, it will prepend the begin transaction to it, just so that you avoid this round trip, right? I hope you guys get it. So there's always be thinking about this kind of stuff, like when are you actually accessing your server? When are your API calls actually hiding something underneath? With .NET, it's kind of nice because async APIs usually tell you where you're going to be doing a round trip, or maybe several, so you're not really sure, but at least, it's a good message to pay attention to that, much more than to a couple of extra allocations that you're doing in your application. I'm just saying this is usually going to be far more impactful on your application perf than some micro optimization that you're going to do somewhere else. So this optimization I just said in NPG SQL, by the way, that is something that's done again at the low level driver. So even if you don't use EF, you use Dapper, you begin a transaction that does nothing. That's a no-op in terms of network traffic, which is nice. We can't do the same thing, obviously, for the commit side of it. That's a different kind of thing. Anyway, there are some ideas that I have about how to even reduce. So let's say you do have multiple statements. You're inserting 2 rows, let's say, into 2 different tables. EF will wrap it in a transaction, because there you really do need the transaction in order to be atomic. Even there's a lot you can do in order to maybe avoid those round trips. So this is stuff that I'm working on, let's say, in the back of my mind at the very least. Yeah, I'm just giving some ideas of the stuff I think about in general. All right, that was like one cool thing, how we could, a very stupid thing, to reduce round trips by not doing them when we don't have to, basically, right? And also to improve our SQL and to coalesce things so that we can get to a situation where we can avoid those round trips, to summarize. Now I'm going to go to a different thing that also happened back in EF Core 7, which I think is pretty exciting. So instead of doing a single insertion, let's do 4 blogs. Crucially, these are 4 blogs, so they're going into the exact same table. That's actually very important here. So nothing very interesting. Let me even add I'm actually doing quite well with this keyboard, I see now. I'm impressing myself. So now we're inserting four blogs basically into the same table, right? So let's see what EF Core does. What's the expectation? What's EF Core going to do? Stupid question. There's various strategies, by the way. It's a simple question, but there's various answers.
For inserts, or
for inserts?
Or one insert with values.
Aha, good. So there's already 2 options here. You can do 4 inserts. Again, I'm going to assume as a baseline they're going to be at least batched, right? We're not going to be stupid and do 4 inserts. By the way, sorry?
or select union with something to optimize the
Values.
Maybe. I don't know it. I don't know that that's going to be better than a single insert with 4 values. That's basically the let's say the efficient version usually of that thing. But that's true. You can do an insert from a table, and the table can consist of a union between the 4 rows that we want. That's a possible answer. That's true.
I thought without table, like select and just passing the values.
Sure, yeah, like a table in the sense of, yeah, exactly, a table that's constructed out of parameters, exactly. That's actually not very far from what we're about to see when we're thinking about.
You can use insert with values
Uh-huh.
and many rows.
Yeah, exactly.
Without
That's the second thing.
Ah,
Exactly.
yeah.
That's a single insert instead of doing 4 inserts. So I was just about to say, by the way, if anybody here used the old EF, not core, when you did save changes, it actually did do a different round trip for every single insert, which is absolutely horrible, right? Just to tell you, these are the kinds of improvements that you get in EF core compared to EF. That's like a thing that we did super early because, of course, you have to do it. That's like, of course. But let's see what actually happens. And I'm going to stress this is SQL Server. This is not going to happen on Postgres the way you see it for very specific, very good reasons you will see. So it's not an insert. There's no union. What you see is, one second. I'm again on the wrong project. I have to remember, I'm going to run this on EF6 and not on EF8 because it's going to be exciting to see this later on EF8. Right. So now we're going to see something pretty ugly. And how many people here know merge? Okay, a few. My condolences in general. Like usually if you know merge, you wish you had not learned about it. That's the general, it's a thing you don't really want to know about in general. It makes your life worse, not better. But we still use it, and there's good reasons why we do this. Okay, so the problem with the inserts, that was a trick question. Of course, this is what we would do. A single insert with 4 rows is, let's say, the correct answer. There's just one problem with this. Remember, EF needs to get the IDs that were generated back from the database, right? It not only needs to do that, it needs to know when inserting 4 of the blogs, which ID corresponds to which blog. It needs to propagate the database generated value into the correct entity instance. I'm starting to talk the EF language now, because it needs to, the right IDs need to go into the right instances in .NET so that they're correct. Otherwise, everything gets screwed up. When you do an insert with 4 rows, you can get back those 4 IDs, but there's no guarantees on ordering. This is the shitty part of the relational databases. If you don't have an order by in a relational database, you don't have order. What you get back is a set. It's not an ordered anything. And there's no way to say output something and also to add an order to tell, there's no way. There is really no way. This is just databases being shitty, to be completely honest. There's no way. So, because EF wants the ID, we are forced to do some pretty bad tricks. And what are those tricks? So what we're going to do is this. I'm going to walk you through this quite quickly. Again, this is EF6. It's going to get better. So we declare what's called a temporary table. This is like a temp table in SQL Server. Database people know about this. Doesn't really matter.
Yeah, table variable, which is different.
Yeah, exactly. They're not very far away.
Temporary tables could be different.
Yeah, this is not a TVP. It's not a temporary. It's not a table valued parameter. It's you can think about it as an actual table on the database if you want, which we're going to use as temporary storage just for this query. Let's say for now, in any case. Then we're going to use this merge. Merge is very simple. It was meant for use for something very simple. The problem is that everybody uses it for many other things. So merge, basically you have a source table and a destination table, and you're going to be merging from the source into the destination, and you give 2 rules. What happens when the row is there and when it's not there. And you can do other things with it as well, but this is, let's say, the basic usage. So conceptually, we're going to merge 2 tables. The first table, and that resembles what you just said here, is going to be constructed from values that we provide as parameters. So EF, of course, sends parameters, and in SQL, we construct a virtual table around them, let's call it like that, an inline table, or in SQL Server, they sometimes call this a table value constructor, like when you do values and you put the things in line. So you see that P0, P1, and all that, those are, maybe I need to go up a little bit so that you actually see it. Right. Here you see the parameters out of the SQL, of course, and you can see the stuff, my blog 0, my blog 1. That's these things right here. There's also this crappy thing here, 0, 1, 2, which is called the position. And that's important because of the ordering thing I was referring to. Okay, and basically what we're going to be doing is from this table, we're going to insert things into our actual destination table, which is blogs. That's how merge works, just so that you know. I just explained to you how merge worked. Now, the interesting things, remember, this is always about the IDs that need to come out. We do output the inserted ID for each row, and also the position into inserted 0, which is what? It's that thing that we declared here. So we sent parameters. We told SQL Server, dump this into this table called blogs. The generated IDs take out and commit into another temporary table. This is quite complicated, what we're talking about here. And then we're not done. I'll go down a little bit. And then at that point, we do select from that inserted 0i, order by position. And the whole point here is this order by. The whole reason for this is the order by, so that we know that we get the things in the proper order. So we sent the order here as a parameter. It's not a parameter, but as a value, doesn't matter. We inserted, we basically inserted these values into the temporary table so that we can get them out here. Pretty horrible, right? It really is horrible. But I will tell you this. This is much, if you have to insert the rows and also get their IDs back, assuming you need to get the rows back, this is actually a very efficient way of doing it compared to the alternatives. I'll just say, it really does work much better. When we profiled it back in the day, like this is actually a very old optimization, starting from 4, this is why I chose 4, this starts to be much better than doing the 4 inserts, basically. This is the idea, 4 batched inserts where you do have the natural ordering, of course. Once you do 10, for example, then doing 10 inserts which are batched, that's going to be much slower than doing this merge, which is a single statement. Just telling you. And this is maybe a nice value of if core. It does magical things for you that no developer would do. Nobody does this thing, like as a normal SQL guy. Who does this, right? But because you're using a layer, and my job, like our job is to do this kind of stuff all day long, you get this kind of thing. That's maybe an advantage of if core, if you want to think that way.
And merge on 1 equals 0.
Awesome, right? I know.
I've never used it.
So this is actually one of the usages of merge, which is safe. There's no concurrency issue here because we're just doing inserts. But many times people use merge in a way that, for example, as an upsert, because the SQL Server has no upsert. This is not an atomic statement by default, so you need a table lock. You need a locking hint in order to. Don't get me started. This is like super bad. Okay. Let's do the same thing now on EF8. And then, as I was doing all my performance investigations, I noticed this thing and I kind of wondered, hey, is there something I can do here in terms of perf? So what you're going to notice here, it's actually quite similar. We still have the same merge, but we no longer have a temporary table before it. And instead of doing output into the temporary table, we just output the position directly. That's interesting, right? It's different. I'll have you know, by the way, remember that in the previous SQL, we actually order by the position. And that means that EF can just read them in order and know that the order corresponds to this. Here, we actually output the position. And that means that EF doesn't know, so the rows don't come back in the correct order, but they have the order inside. So EF needs to do the correct lookup. That's a change, right? But that's not the important part. The important part is, it turns out, when you know database as well, you know that actually doing a temporary table is super expensive. It's really super expensive. It's so super expensive that if you remove it, I got about almost times 3.5 increase in performance, like 3.5 times better performance when removing the temporary table, right? So I could do the benchmark, but I don't want to keep you here too much. I actually have a benchmark.net, right there that's doing this, but I'm going to skip it. You're going to have to take my word for it. On my old computer, this was like around 4. Here it's around 3.1. I did this like in the train while coming here. It's really a massive performance change, right? But another thing, once again, I'm going to be harping on this again, is that this is now a single statement because there's no more create temporary table, merge, and then select. So what do we do when it's a single statement?
No transaction.
No transaction. So we also kill 2 round trips with a single stone by removing that temporary table, which is another source of like huge perf improvement as well. Okay, at this point, we have to stop and kind of, you're probably asking yourself, so why was EF doing it the other way? Like, what's the point of doing a temporary this whole complexity? Why did we even do it? And we're not completely dumb. We're kind of dumb, but we're not completely dumb. It turns out, I'm talking about SQL Server now. It turns out, so again, disclaimer, I'm a Postgres guy. I don't believe that SQL Server is necessarily the nicest, best database like in the world. I'm going to say it like this in a very careful way. So one favorite feature of SQL Server is they have a feature and they have another feature, and if you try to use the two together, then it's just going to tell you arbitrarily, oh, that doesn't work together with this. This is like something I get all the time with SQL Server. It's very janky, so it's very disjoint. You have a lot of features that work nicely, but then if you happen to do another thing, then it's not going to work anymore, and you have to find some workaround. Concretely in this case, the output clause, both on insert and on merge, if you use it like this, so just output directly to the user, that's incompatible with table triggers. That simple. It's like, it's so arbitrary, I didn't believe it myself when I first saw it, but if you try to use this and the blogs table happens to have a trigger on it, this will fail with a very explicit message saying you cannot use the output clause with a table with a trigger. For some reason, if you do output into, that's a different clause, of course, that does work. I don't know why. There's probably some reason there, but I don't know it, and I don't really want to know it, to be completely honest. So when EF Core was first being constructed, the goal was, of course, to do maximum compatibility everywhere. It should work everywhere, right? Which is, you know, we're also Microsoft at the end of the day. This thing is the data access layer. It should work regardless of whether you have triggers or not. So the choice was done to go in a direction that's universally compatible. It's not a wrong choice, but it kind of is in the end, I think. I also think that, you know, we were writing EF Core 1 and nobody had time to do deep perf investigations like we're kind of more doing now. So nobody was aware that this was like a ×4 kind of slowdown because of this. So we had a nice moment, you know, a year ago where we sat and we had this discussion. Should we basically have an opt-in to say, go fast, but then it's incompatible with triggers? Or should we do the opposite? Break everybody with triggers, right? Like switch to this by default and provide an opt-out for those people with triggers. So what do you think we did working at Microsoft?
We gave an option.
But which way?
To choose.
But what's the default?
So I guess the same
The default is the interesting question here, right?
without a trigger. Default is let it work for
Don't break it, don't aggravate everybody.
Not break it and provide an opt-in instead of an opt-out.
Yeah.
We went with the break. We actually broke everybody. We didn't break everybody, of course. People with triggers is a certain segment. Of course, we have no telemetry. We have no idea how many EF Core users actually use triggers. No clue in whatsoever. But we assume from our interactions with users on the, you know, it's not 100% for sure, right? So what we did, and I do think this is super important, when you get this exception, we actually catch it in EF Core and we raise a very informative thing pointing you to the doc page that tells you, put this option now on EF Core and you're back to where you started. Which is, what I'm trying to say is, I personally believe things should be perf first. So compatibility is important, but in this sort of case where you have a big performance gap, being performant out of the box for me trumps the universal compatibility as long as the failure is very fail fast. So if the user will find out immediately, shit, this doesn't work, but there's all the information needed in order to make it work via the opt-out or whatever, that's the perfect situation for me. What's more important for me is that the entire world doesn't run slower just because there are a few people with triggers, right? Mm-hmm. And the worst thing about perf, unlike bugs or behavior changes, is that nobody knows about perf. Nobody actually profiles and looks at this stuff. Nobody will know that they need to go and opt into the fast mode. That doesn't work that way. So what you want to do, this is at least my philosophy, and not everybody agrees, even in the team that I work in. What I believe is that you should really make the effort to really provide by default very good performance maybe at the edges it will not work for some people, and then they can go and do the the correct opt-ins, opt-outs, whatever is needed. So I'm actually very happy that we managed to go into optimized mode and do such a breaking change. It really proved that I think that we made the right choice. We got a flurry of bugs, like people said, hey, my stuff doesn't work, because they failed to even look at the exception message. Of course, that's how it always works with users in general. That's fine, I know how it is. So we politely tell them, look, just do this. And then they said, okay, fine, and closed the issue, and we never heard from them again. This fear, even at the Microsoft level, that, everybody will, they'll send terrorists and kill you in your home or whatever. It doesn't really work this way, as long as you communicate well, you provide the correct opt-out, you provide the correct, docs, and also pointers to lead people to those docs. If you do it right, you can do a breaking change like this, and it's going to be okay. That's basically a thing that I'm telling you, which is definitely not the traditional Microsoft way of thinking about this. But I'm happy that we got to do it.
With Trigger?
Sorry?
What is the solution with Trigger?
With Trigger, we just go back to the old thing that you saw. So we just revert to the code is still there. There's a switch there. If you tell us you have a trigger, by the way, you can configure it per table as well. So we know if specifically you're inserting into a table with triggers, etc., etc. You get the idea, right? So it's a pretty good situation, I think. Yeah, it's fine. You can ask questions during if you want.
Why is on 1 equal to 0?
That's just the merge. That's just the merge syntax that makes us go into the insert, because merge has two legs. One when there's a match, and one when there's not a match. When there's a match, we actually don't want to do anything. That's the whole point. Like anyway, it doesn't. That's the less important part, right? That's the less important.
For insert, yeah.
Yeah, this is an optimization specifically for insert. Update is a completely different world, and we don't use merge for update. That's very important. Adam?
Shay, I have a question. How much did it take you to implement this change versus how much did it take you to convince everybody to this change?
That's a pretty good question. No, look. To be completely honest, so I'm the cowboy in the team, right? Like, I'm in a team that's much more traditional in general. So I'm the guy who says, let's break it, and all that kind of stuff. But in this case, when I showed ×4, people kind of, they had to shut up. Because seriously, like at some point, what are you gonna say? It's ×4 perf. Like, come on. Like, people like you are sitting there to get, I don't know at this point what sort of percentages. I mean, I also work in NPG SQL to get if we get a 3% improvement, that's a super nice story. And here I'm coming with 400%. I mean, it's like a no-brainer. Anyway, cool. Question, yeah. I still have stuff. I'm just saying, yeah. There's still stuff, but go ahead.
A different topic. I'm curious how EF8 would play with bigger data sets. What is the limit on the...
You mean when you insert like a huge amount of data? So first of all, I'll say that's not a great scenario right now for EF in general. So what we generally say, if you do what's called a bulk import or a bulk copy, this is not the good way to do this. We actually do limit it. First of all, SQL Server has a maximum of 2,100 parameters per statement, so we can't go over that. We're using parameters. We'll split it and do two round trips. Because we have to. Same thing, there's a maximum number of rows which you can control via a tweak. There's a parameter that you can use. You can even say that you want less. You can say that you want only one insert per round trip if you want. So EF exposes the knobs to do it. There's logic there, I'll just say. But all of this is mainly complicated because of various SQL Server requirements. On Postgres, by the way, there are none. So you can send as much as you want. The upper limit on parameters is absolutely ridiculous. So there's no problem here. But here, I mean, I could talk so much about all this low-level crap. We just don't have the time.
Will it handle 4,000 records or more?
Not in a single merge, but EF takes care of. So you do the save changes. Underneath, we will know that we cannot do it in one statement, and so we'll do two. Okay, so that's not your problem. It's very much my problem, let's say. But it will work. So save changes will always work. If it doesn't, that's a bug that we need to fix. We're an abstraction. We take care of that kind of stuff for you. We're a higher level component. All right, I do want to continue just a little bit more. Yeah, definitely. Yeah, I'm only 37 minutes in, so okay. So I'm gonna show another fun, little fun story here. What we're gonna do is, I'm gonna keep this code for later. I'm gonna copy it, and we're gonna go back to inserting just a single thing. So, once again, I'm super slow with my new Mac. But we're going to add you saw that there was a post one-to-many relationship, so let's do posts. We're going to use this super nice new collection initializer syntax, and we're going to do a post with whatever, a title of foo. Okay, let's just do it like this. I'm going to add spaces because I can't watch it like that. And now we're going to run it on EF6. So remember, a blog, there's a table of blogs, there's a table of posts. So now we're talking about relationships between tables. This is all very, very standard relational stuff. Anybody with some database experience knows about this. So what you see is two commands here, right? There's the upper one where we do an insert into blogs. You see we're on EF core 6, right? So you have the insert plus select pattern that we saw before. That's going to disappear very soon, right? And then that's a round trip, and that's a round trip. These are two round trips. Why do we have two round trips and not one? Sorry? For the ID, exactly. The ID of blogs is database generated, and it has to be inserted as the foreign key on the posts, right? I'm just making sure everybody's on the same page. So this is a well-known problem. You have to insert and then get the key back so that you can insert the second thing. That's just how databases work, right? In general, that's what you get when you have a database generated thing. Okay, that's pretty cool. Now, and nothing interesting to show at this point. But now I'm going to do something a bit different, and I'm going to change our IDs from ints to GUIDs. So you all know or maybe you don't, but there's this big discussion or religious fight in the world. Should you use GUIDs or not? Should you use ints? Which is better? What do everybody has a side. It's like Emacs and Vim or whatever your favorite religious war is.
Yes, but you should custom to ints.
Sorry?
Yes, but custom to ints.
There's also that, or GUIDs as strings. That's another favorite one. We love that one as well. All right, something has happened here, obviously. Things look quite different. So there's no more insert plus select, right? Instead, you can see that we're actually inserting the ID, and the parameter is some GUID from the client. So maybe you don't know this. This is EF conventions, let's say. But in EF, when you have an ID that's an int, EF by default makes it into a database generated thing with identity. But if it's a GUID, it's going to say, wait, we're going to do something better. We're going to actually generate it on the client for you instead. Why? You'll soon understand why. I mean, we just talked about basically why, right? So EF by default does client-side GUID generation. All right. You can of course change it. You can switch to server-side database generation, GUID generation. There's also a whole thing about sequential GUIDs. So which GUIDs, if you do random GUIDs, you're going to horribly pollute your indexes. By the way, that's very, very bad. You don't want that. So especially in EF, but in SQL Server, you want what's called sequential IDs, GUIDs that increase monotonously. And in a sequential way. There's a whole algorithm which EF replicated client-side so that it can generate efficient GUIDs. Even there, the reality is more complicated than I can talk about here because that's the world, but in any case. So, okay, at this point we have an insert and there's no more database generated anything. We're not getting back anything from the server. So why do we still have two round trips is the question, right? And of course you probably know what's coming at this point. If we now switch to 8, exactly, big surprise. We switch to 8 and we do the same thing. We get a single round trip. So if you now insert a principal and a dependent, where there's no dependency in terms of data between them, EF will now batch everything. All right? And this is a good point to say. Again, I'm trying to also get you to have an idea of how much complex stuff EF does for you under the hood. Notice that in the first example, when we still had ints, right? EF knew that it needs to do save changes via 2 different round trips. So it knows that stuff. In fact, there's a whole topological sorting algorithm inside the update pipeline of EF to order all of the different commands to find out the dependencies between them and to do them in order. There's various problems even, for example, if you do an insert and a delete for the same table with the same ID, there's a unique constraint there, right? If you order them incorrectly, if you do the insert before the delete, that throws because that's a unique key violation. You have to delete first and then do the insert. Making sense? That's another type of ordering or topological sorting kind of problem that we do. So there's a graph of updates that we do inside of EF Core. We analyze that thing, and we figure out, the correct way to do it, and also where we actually need to break for a round trip because of a data dependency, because of what you just saw, right? Make sense? All right, I'm gonna switch back to IDs now, because I'm not done with this example. There's still something.
One quick question.
Yeah.
Shouldn't it throw while it work? Because you didn't change the line 58. It's
Yeah, foreign key is still integer, not fluid. Yeah.
yeah, it worked with int.
I think, yeah,
It added another column.
yeah,
with one
that was
ID.
bad. Exactly, that was bad on my side. You're
Yeah,
right.
but why did it work?
That's a good question. I'm willing to look at it, but that probably means we'll get out of here a bit later. So maybe we shouldn't. Yeah, so we do have two IDs. So, okay, so what it did, this is maybe not an ideal behavior. I know what happens here. Because it didn't find a compatible, because blog ID isn't compatible, there's a blog ID 1. All right? This is this thing here. And it's a question because, already we do this heuristic where we recognize blog ID. It's a sort of heuristic anyway, right? So once you step out of it in terms of the type, I actually agree that we should maybe have thrown in this case rather than do the other one, but I mean, that's decisions.
If it works.
I mean, you could say that this works, I'm not sure if this is what the user actually wanted. That's another question.
Then you fix it and people call. That you broke things.
I mean, here I don't have a 4x performance argument that I can, that I can pull out. Let's switch back to IDs. Okay, so of course, once we switch back to IDs, I remind you we're still on EF8 now, so now we're on the new stuff. Of course, with int IDs, we still have to do 2 round trips because we have the data dependency. But now finally there's a feature that can come and help us out. I mean, like when I just, this whole exposition maybe causes you to want to switch to GUIDs, like run and switch all your ints to GUIDs so you can get that, that round trip reduction and so on. But instead of doing that, EF also has a feature. This one I'm pretty sure nobody knows. Nobody knows about, either in EF or conceptually. I'm gonna go to blog and I'm gonna configure the ID property to use something called high-low. Anybody know about high-low? Surprisingly, a lot. I'm actually very surprised. High-low is something we introduced a very long time ago, and it was kind of useless until EF Core 7, in fact. But now it's kind of useful. What does high-low do? I'll demonstrate just by looking at the code. That's the best way, at the SQL, rather. So what you see here, first notice that on post, we have the ID and it's called identity. That's the normal thing. That's the database generated identity, but not on blogs. Because we did use high-low, this is no longer an identity, it's just a normal int that cannot be null, all right? So we removed the database generated thing, right, that we were doing up to now. But we did something else. We also have this thing now here. Sorry, let's see where the, okay, we created a sequence called Entity Framework High-Low Sequence. That's above, doesn't really matter. And now, when we did the save changes, EF got the value for that high-low sequence. You know what? I will show you the sequence creation. I think you guys know what's coming, right? So here's the sequence creation. This is the name. Start with 1 and increment by 10. That's an unfortunate number in my personal opinion, but doesn't really matter. So now we have a sequence that every time you get a value from it, for people who don't really know about sequences, it's basically another auto-incrementing mechanism inside the database. You can get one explicitly, and every time you get one, it will jump ahead by 10. That's configurable. The number is not important. So what is the point of all this? The point of all this is now when you do save changes, EF Core goes to insert a blog. It looks and it sees that its high-low cache is empty. It has no IDs. So it will go and do this thing here, the select next value. Now it got 10 values, basically, right? Now it has 10 values cached, so it can insert 10 blogs without doing a database round trip. And now when you do the insert blogs, it just supplies that ID here, which got generated earlier, right? So basically, it's a way of pre-caching database-generated IDs in order to reduce the number of round trips when you're inserting a principal with a dependent in the same batch. This is basically what I'm explaining. All right. So this allows you with ints to get back to the same places, the same place that you were with GUIDs. All right. I hope that's kind of clear. There are some complexities and disadvantages, as always. If your application goes down, those unused ints are going to be lost, right? So you're going to get gaps in your IDs. You should never care about something like this, but you do need to know that it happens.
Inserting to identity column. Inserting to identity column when something goes wrong also gets gaps. So.
It could. That's also true. Exactly. And you really shouldn't care about it. I have one last thing. Is it still okay? Are we still fine in terms of time? Very cool. And then I hope maybe still some questions. So my last thing, and that's the most important thing that actually happened in terms of updates, more important than everything that I showed you. Up to now, these were internal optimizations. Okay, you don't need to know about them. They're cool and interesting, and you can learn a lot about them for optimizing your own stuff. But as EF Core users, you don't care. Things just got faster for you, basically, right, under the hood, which is the best kind of optimization. But now I want to talk about something else, an API that we actually introduced. So I'm going to remove this thing. And what we're going to do is, we're going to go, let's do it like this. We're going to go back to the code here that inserts 4 blogs, just for fun. Now I'm going to do a little piece of magic just to clear the context, so that basically clear the state, make sure that it doesn't track, that this is not important, it's not interesting. This is just so that now I can start from a fresh context. And now the job that we have to do, the thing I need to implement, is to delete all the rows from the database. It's a very simple task. So I'm going to do this in the traditional EF way. When you need to empty a database, you're going to do this. I feel very bad about what I'm going to show you, by the way. I'm going to say a few words about that. So ctx blogs, remove the blog. And then afterwards, await, once again, save changes async. This is the traditional way of doing it with EF Core. EF Core is a change tracking / unit of work oriented ORM, right? Everything conceptually works by loading something into the change tracker, changing state, and then persisting that back to the database with save changes. That's what EF Core has always been conceived to do. This is its origins for desktop applications, like a WinForms application where you bind the form, so the values get tracked, and then the user changes the form, and then EF finds what changed and persists it back. This is the world where this all comes from. So this is also the way that you do a delete. Now I'm going to run this, and we're going to talk about the perf. All right. So what we get is a single delete statement for each one of these blogs. By the way, I'm on EF Core 8, right? This is not a change between EF6, EF8 in terms of behavior. This is a different kind of thing that I'm showing. So if I'm deleting 1,000 blogs, then we're going to get 1,000 commands here, right? Okay, so I'll open it to the crowd. Where are the perf problems? Not you, Adam. It's not hard.
So we can use delete from blocks.
That's the answer. But first, where exactly are we losing perf here? That's the first thing I want to
fetch each row, just because if you delete by IDs, then you need to select each row. So
exactly. So the problem is actually not on the screen. One problem is this. So we have a query that actually downloaded the entire table over the wire. Think about the networking to EF. Whereas we don't need that data. We're not going to do anything with it. But that's not even the only thing.
Why not just truncate?
You're talking about the solutions. I'm talking about the problems. I'm trying to make you understand how bad the current thing is. Okay, so I'll help you out. It's not just that you downloaded the entire data, which I admit is probably the worst. You're also doing
SQL string.
What's that?
SQL string will be huge as well, and you need to pass it over the network.
SQL string?
Yeah, the entire request must be huge, right?
You mean the data coming back?
The delete.
This one. If it's 1,000 rows, that's going to be big. But honestly, next to the other crimes, this is nothing. I'm serious. You're also doing 2 round trips, 1 select and 1 delete, right? There's no need. Then you're also doing transactions. I was about to get to this. You said this.
You are locking row by row as well.
That's another aspect of it that I'm not sure about how it's going to be better in the other solution. Like the other solutions are also going to be locking your rows, right?
So is the issue that this causes a lot of
We're not done.
traffic?
So yeah, the network traffic because of the download of the table.
Traffic in the database on the transactional log, because you do delete one, it's
Probably.
outputs are interesting.
Probably you're right. That's I didn't even think about this aspect of it. You're probably right. But another one that I have, all this also gets loaded into the EF change tracker. The EF change tracker, first of all, is, it's a big piece of machinery. It's not like super optimized in general, not in the hyperf kind of sense. But how does change tracking work? Like when we get a row, in order to know if it changed later, we need to be able to compare it later with what we loaded to know what the differences are so that we can persist only the differences. So how does that work? EF snapshots the row when it comes back. So it creates a duplicate of the whole row. When it loads, this is what happens when you use change tracking. You have to be aware of this. This is the point of this talk as well, is to make you aware of what actually happens to support all this nice high-level stuff that you're doing, right? So not only did we transfer all this useless data across the network, we also duplicated it in memory in .NET. The memory requirements of your .NET process are now not great. They're not just proportional to the data, where you're not even using the data, you just want to delete it. They're twice your data, in fact, because of the snapshotting mechanism. Basically, it's a catastrophe, right? And the answer, as everybody knows, is to do a delete, right? Maybe a truncate even. This is specifically for the case where you want to empty the table, but we're not just wanting to empty the table. Let's say we want to delete all the blogs with a certain filter. Then you can't truncate anymore, but everything we just said will still be relevant, right? So think about the more general case. All right, so we're in EF Core 8. The new feature, I mean, this is so obvious, I think, but I'm just amazed it took us until EF Core 7 to do this. How many people already use what I'm about to show? See, that's exactly why I said I'm going to go and do this talk, because so few people know this. It's really interesting. So we're going to go and we're going to do delete async, semicolon, and we're done. Execute delete is basically a way to model the SQL delete statement. So if you just do this, you're telling EF to just delete everything from the database. I'm just going to run it, although it's completely trivial. There's nothing interesting in the SQL that you don't already guess. That's it. So instead of all that round trip shit with all the data and the change tracking and the duplication in memory and all that crap, we just sent this SQL string for 1,000,000 rows, and that's it. Obviously, this is, there's nothing to say about this. I did like a few, just for fun, I did some benchmarks. I saw differences between 2.5 seconds to like 3 milliseconds. It's like, it's not even worth benchmarking this kind of thing because it's so ridiculous, right? But the point here, and that goes back, we're not just interested in truncating. This would be quite useless. Nobody wants to truncate their tables. This is a fully link thing that you can do. So you can do where the ratings is lower than 3. Delete all our low rated blogs. So you're basically using link queries here. And then you see this where clause. I'm going to do something even fancier. Let's say where and also lowly rated blogs, and also blogs which have at least, let me, so that you can see me actually type. Any post that has a title of foo. I'm kind of making this up, right? So this is now starting to be a full-fledged link, complex link kind of thing. And if you do this, you get this. This will be the translation for it. So this works. Basically, anything that works as a query, in general, there are some caveats, is just going to be transformable to a delete. You are using now a link expression tree, or a link expression if you want in C# to identify the rows that you want to touch. But instead of selecting them out, you're using the final operator, the terminating operator here. Instead of doing toList on it, you're doing execute delete. So the same rows set that was selected will get deleted instead of queried. That's basically it. And of course, we did the same thing for update. It's exactly the same idea. So I'll just show it. And at that point, I think we're really done. So you can basically do await. I'll just write it out like this. So let's do aware just for fun. All the low rating blogs. And then we're going to do an execute update. With execute update, of course, things are a bit more complicated because you have to tell it what to update and how, right? The setters. So the API looks like this. I'm not too happy with it, but I also have to make some, compromises with people in the team sometimes. So you say, let's say that we want to change the blog's name to bad, all right? So this is a way of expressing set the blog's name to bad. And we're going to chain a second one. I'm not writing it out super nice. Be rating, and I'm going to say increase the rating by 1. Give it a bump. Let's say it like that. Now I'm showing those two because they're different overloads. It's a little bit interesting, right? So first of all, we're using this because in LINQ you can't put an assignment inside an expression tree. I hope you guys, maybe you don't know this, right? So this thing here inside the where, that's an expression tree, right? This you know. And there's severe restrictions on what you can put in there. You can put only expression syntax and no statements, basically no statements at all. Even in expressions, there's some restrictions on what you can put, just to keep it clear. So I would have loved to be able to just say something like b.name equals something, but that's just not possible in C#. That's a C# limitation. One day maybe we'll be able to improve it. But here we're expressing so via an inferior mechanism, but it's still okay. Set the property name to a constant. But in the second one, the value thing is not a constant, it's actually another lambda. And this here is an expression tree which we translate. Okay, anything inside those, the arrow there, we actually translate to SQL because of how LINQ works. So if you look at it, you get this here, right? So you get the two setters that we said with the where rating is less than 3. So obviously this is the right way to do things, right? I will even say, if you forget about performance, if you just compare how the code looks between, let me do a fair comparison here, like between this code, this piece of code here, and the one just below, I choose the second one every day, right? It just looks a lot better. It expresses what you want to say, rather than this imperative loopy kind of code, right? So it's just a better way to do it. However, and this is my final remarks, and then maybe a question or two if there's still time. This does not replace the first mechanism, the change tracking mechanism. They are complementary. There are many cases where you want to use change tracking and not use execute, update, and delete. Execute, update, and delete are great when you know exactly what you want to change. You know that you want to delete a thing with a given ID, or you want to change some property, some specific property of this thing with an ID that you already know. Perfect. That's exactly what you should use. It allows you to express that precisely. But there are all those scenarios where you don't know that in advance. For example, you bound a form, WinForms, whatever, to something, and then you want to only persist the changes to the database. In this case, the SQL is not even the same every time, right? It's gonna the list of things to update is gonna be completely different, right? Execute, update is also, and delete are also more low level. So, for example, if you know concurrency tokens for optimistic concurrency, that's something that save changes does for you automatically. Whereas execute, update purely is a low-level representation of SQL update. So it does not do this kind of stuff for you. You can still do a concurrency token, but you have to do it yourself. So it's a much lower level kind of thing. Okay, much more lower level, but it allows you to precisely express what you want to do if you can, if that makes sense. Once it starts getting dynamic and weird, then this is no longer the right tool. Also, I'll just say, remember I talked to you about all the topological sorting craziness, like when you are doing a lot of inserts of a graph, right? Then there are dependencies. You need to get the ID from this, and you need to order the delete before the insert. All that crap is super hard, believe me. It's why people use EF, is because we take care of all of that stuff. It's one reason why people use EF. If you start using this, then this is, you're doing everything yourself at that point. Okay, that's important. And one last point about this is that when you do execute, update, or delete, they will just do the thing at that moment. So this does not add something to the change tracker to be executed when doing save changes. It's at that exact moment, and this is why it has the word execute in the API. This does not interact with the change tracker in any way. So if you have something tracked, that's your problem. I mean, we don't care. We just execute this SQL as it is. And if you want to mix the two, be careful. Be sure that you know what you're doing, right? That's very important. And also it means that you cannot batch these together right now. So if you want to do 2 updates to 2 different tables, this will be 2 round trips. Whereas with save changes, you can actually do them in a single round trip. right? So it's really complicated at the end of the day. I actually have a thing I really want to do, but it's definitely not happening for 9, for allowing you to also batch multiple queries or execute updates or deletes. And at that point, this will be perfect. But currently, you can only execute update or execute delete at a single point, and that will execute at that point. They're not batchable, basically. All right. I had a last slide.
Sorry.
I just had a last slide to give some resources, or did you want to talk about the code?
About code.
About the code?
Update, yeah.
Okay. This code?
Yeah. Execute update.
Yeah.
In the entity framework class library,
Yeah.
you know, yeah.
Of course. They have something as well.
It was more simpler, the update, yeah. The same thing, native update to SQL Server, to SQL, but more better syntax.
I investigated them. So this was introduced in EF Core 7, just for background. Before that, there were various extensions to EF Core that did the same thing before. All of them could not do it as if they are inside EF Core, because there were various features and things that they could never do. For example, if I remember correctly, there's no way it would have been able to translate, like if I put in the where, if I start to do something super complicated, if I remember correctly, I don't remember, I did this investigation a year and a half ago, they would be severely limited. So I don't remember what the exact simpler syntax looks like.
Yeah.
I just don't remember, but there's a very good chance that it's simpler also because it doesn't support certain things. I'll just say it like this. I'll be happy to look further after or whatever, to see exactly and to compare, because I just don't remember anymore. I mean, this kind of thing, you have to do it inside EF. You can't, like, to do it really, really, really properly. What they did was amazing work, absolutely. But this sort of very fundamental feature, it belongs inside the core. It's not an extensibility thing. You have to do it. Yeah.
Is there any way to get a callback about the updated or deleted data?
So EF has a general mechanism called interceptors for that get invoked at various points in the thing. You can intercept also any query. So you can also intercept an update or a delete in the same way. So you can tell EF Core, you can register any time that an execute update happens, call this function.
Oh, okay.
That's called interceptors. That's the word you should be looking for. Not to be confused with C# interceptors, which is the feature they just introduced now in C# 12. Very different thing.
Are you planning support in SQL row SQL query? Yeah?
Raw SQL, yeah.
Complex objects. I know that 8 version support complex entity, but without mapping nested objects. Yeah.
Not related to this in any way, or
Yeah.
not just you're asking not related to updates now.
Yeah. Not this. My question is, are you planning support complex objects, complex
types?
Yeah, complex types in SQL row query.
Right.
Like a Dapper, yeah, with mapping.
Absolutely, yes. So this is something, complex types were introduced just now in 8. It's a multi-year thing. It's a big effort. There's a lot of stuff missing. I know specifically that raw SQL query support has some problems. So this is something I cannot tell you that it's going to be done for 9 because there's a lot, and I'm not sure this is the most important thing. Before this, we want to allow mapping them to JSON. We want to allow making them optional. Right now, they can only be required. Those are the really 2 big things, and there's 2 other things on the list before we talk about, I think, raw SQL. This is, sorry, that's how it is.
You have to wait for time. Yeah.
So this bug we actually discussed 2 days ago in the triage meeting. There is a chance this might actually be done. Now I'm remembering this specific bug about the mappings for complex types for SQL queries, and there's a good chance.
You store only on simply nested objects.
Yeah.
JSON.
It's a bug. It's just a bug. I mean, of course it should work. Nobody. Yeah. There was a hand.
Yep. Sorry, you mentioned that execute update is seen it doesn't interact with change tracking.
Correct.
What I didn't get is what happens if kind of entity which is being updated was it injected?
Good question.
Throws some exception, or it just
Nope. So
clears?
the way you need to think about it in general is that this is a database, and anybody could be concurrently changing the data in the database, right? So if you do execute update, it's as if somebody else did it. You can think about it this way. Of course, you don't get an exception when somebody else changed. I mean, we don't even know that somebody changed the data in the database, unless you use a mechanism like optimistic concurrency with a concurrency token. This is the way to do it. For example, maybe you're not aware of this mechanism, but you can say, okay, in 2 words, right? When you load something from the database, EF snapshots it. A concurrency token is just a column there that changes every time we modify the row automatically. When you tell this to EF, then when you do save changes, it will do the update, but it will add a where only in the case that the concurrency token in the database matches what it loaded when it loaded. And when that is not the case, it sees 0 rows were actually affected, and it raises an exception, a concurrency exception for you. So that's a built-in feature of EF for getting concurrency exceptions when somebody changes your data from the time between your query and your save. And it will work here as well. It's this. This is like an external change. It's the same.
Okay, just from the, it looks like it's a way for a user which is not prepared for such a thing.
Absolutely.
Kind of to
Absolutely.
Inconsistent state.
I completely agree with you, and that's why if you look, so there's docs on these 2 features. Like I spent a lot of time writing those docs, and one of the things we say very clearly: don't mix them. Don't mix save changes and execute update and delete. Just don't do it unless you really now are prepared to understand how it's going to work. So I completely agree with you. And we discussed this danger a lot when introducing these features, but that's not a reason not to do it, basically. That's what we came to.
Great power.
Exactly.
In the example with high-low, you said that you don't like in the sequence, you said that you don't like 10 as the number of fetched IDs. Why you don't like it?
10 is ridiculously low, in my opinion. Like, if you're using this, the whole point here is to significantly reduce the number of round trips. If you now have to do a round trip every 10, I would put it at 100, for example.
Okay, so
personally.
is it configurable?
Yeah, absolutely. It's just a shitty default, if you ask me. By the way, another shitty thing that this does by default is to create a single sequence for the entire database. So all your tables get their IDs from the same. I don't know. I wasn't in the team when these decisions were made. But you can also specify when you say high-low a specific sequence, and then you can manage the sequences yourself. So you can basically use EF to create a sequence as much as you want, and then configure high-low to take from whichever sequence you want. It's all up to you. And because this is anyway a super advanced perf kind of API, it's fine. You need to figure it out anyway, right? That's kind of what I'm trying to say. This is why we're not gonna break and change behavior so that the default for high-low is more appropriate. I think it's a bit much, basically, because it's an advanced API.
Can you add some kind of explicit where in this case for execute update that would make it respect the optimistic concurrency token?
Yeah, but you have to do it yourself. Okay. So basically you have to hear, let's say, for example, I'll give you an example. You can do blog equals context blogs single. I can't bring myself to write synchronous code anymore. I'm sorry, I have to add async. It just doesn't work. b.id equals 8. So here I loaded a specific blog, right? Here what I'm going to do is I'm going to do where b.id equals 8, and also, and this is where it happens, b.version, and this doesn't exist right now, but let's assume it does, equals blog.version. And there you have it. But now...
Two round trips, right?
Sorry?
That's 2 round trips. Right
now. One for loading and one for, but that's inherent in the idea of optimistic concurrency, right? Yeah. Because you have to load it and then in order to have the interception in the middle, right, somewhere. But I'm not done. This is also why rows affected. This thing actually returns the number of rows that it affected, which is what the SQL update and delete return, right? As everybody knows. So we just return it for you as well. And now it's up to you to do an if this was 0, raise an exception. That's exactly what I was referring to earlier when I said it's possible, but now you have to do it because it's low level. This is what I meant. You can do it, but it's not like, hey, I just defined a concurrency token and I do save changes and it just works.
But it doesn't make sense, right? Because you could just go through the change tracker for one object.
So there's many reasons why you would do this. For one object, maybe, for example, if that object happens to have a super huge property, EF always can only load like entire properties for change, entire entities for change tracking. So that's a reason. Or for example, you can do something more creative. You can select 100 blocks and then update all of them and check that all of them were affected. And if not all of them were affected, you can still raise the exception and roll back the transaction. So
it would make much more sense if you would select just the ID and the version, right, in line 26.
Yep, it would. Exactly. Yeah, I'm just writing the code like this, but you're absolutely right. Like the proper way to do it is to do a select first into an anonymous object. Exactly. I'm even writing it out. And then single whatever, right? You get the point. I'm not writing super nice code, but that's the idea. You have the tools now, the low-level tools. I'm not saying execute update should always be used. It's not the right answer everywhere, but it definitely is very much the right answer in some scenarios.
So there were some complaints about the await and async at some point in EF core. If I remember correctly, that there were some concerns about the async performance in some cases in previous version. Is it now completely?
I think you're talking about the async performance of SQL client, not of EF.
Oh, okay. Maybe, yeah. But I remember there were some.
Yeah. So we get a lot of bugs that are actually bugs in SQL client. A lot, because people don't make the distinction in the stack. SQL client. Next question.
Yeah, I have one. So if I'm using a Postgre version, then I can expect a bit different optimizations done there with .NET 8. Like you mentioned earlier that the optimization will throw if you have a triggers. And I was like, okay, I have a triggers, it will die on me. But then, okay, I'm using a Postgre.
Right. So
it will not die on me, but will it also get some performance improvements?
So, for example, the transaction elimination that the first optimization happens on Postgres as is. Exactly the same thing. It's a general relational thing. It doesn't have anything to do with a specific database. The second thing that I showed was for the merge. This is something that we only do on SQL Server in the first place, because on Postgres I measured, and just doing a lot of inserts is not that bad compared to SQL Server. So the performance, there's not a good justification for starting to do something so convoluted like what we did with the merge, which is also why there's no merge there and there's no problem with triggers. So everything is fine, basically, already. We did get rid of that transaction, and also the reducing the round trip for the, if you send like a dependent and a principal with the data, without data dependency, like if you use high-low basically, or GUIDs, you get the same performance improvement on Postgres. Because that's not database specific, that's a EF stuff.
What do you think about the idea to add to EF remove by ID?
I mean, you can do it now, you can do it.
Yeah.
So you can do it, it's as easy as this now, right? We discussed this, by the way. That's removed by ID now. Now, some people said, there should be like, we should have a lambda here. Which is like which is not, I mean, it makes sense. It's like first or default, right? Where it has a lambda that tells you which one instead. There are reasons why we didn't do this. I have some plans in the future, specifically delete and update in databases can also return the rows that they deleted. So we need to extend these APIs in the future. And if we start adding the lambda there, that's going to limit what we can do in the future. That's kind of what I'm trying to say. You have to think ahead always in this kind of project, years ahead. But this is already pretty good, is what I would say, right? And also, we're not blocked from adding the lambda version later if we want. So,
from 8th version, execute delete async. Here I was another idea. I prepared a fake object, new block with ID equal with attach.
Yeah.
Yeah, and save changes.
Yeah.
Sorry, and change state. In change state.
Yeah, that's the way.
By manually.
This is the way you do it with the change tracker. If you want to do it a bit more efficiently, but this you can do only in certain cases. For example, if you want to delete all of the blogs with a rating of 3, like what I showed, you don't know their IDs. You don't know them. How would you know? So you can't create those fake objects and attach them, right? Yeah. This works when you know the ID, and that's fine. Yeah.
And the finish, I created extension methods for me.
Sure. Yeah. I mean, sure. That's perfect. That's how it should be.
Can you show that slide again?
The slide with the resources. Yeah. Sorry. Here you go. This is some. The blog. There's a blog post and there's some documentation which covers some of what I showed, but of course not in the same level of depth and so on. You're welcome to look at it. We also did, by the way, we do every 2 weeks, we do a community stand-up, which is basically just me and another guy from the team talking, like for an hour and a half usually. So you're welcome to look at this. We're now talking about concurrency, by the way, right now. Like next week, we're going to have the second session on concurrency. If you got like database concurrency and concurrency with EF, in case you're interested.
I have a question about round trips because sometimes you need to anyway just begin transaction, do some actions, etc. Is it because I sometimes saw that there are 3 round trips? Is it just possible maybe to send begin transaction with additional payload? Made in one shot, and that
already happens when you're using Postgres. That I mentioned this before. So at the lower level, EF thinks that it's doing. I mean, it doesn't think. It just calls begin transaction. It doesn't know what happens there. Under the hood, with NPG SQL, when you do begin transaction, that's a no-op. But we could, in theory, also implement this optimization at the EF level, but it really belongs at the lower level. And because then everybody benefits from it, like Dapper and everything. This does not belong at our layer, let's say. I'm sorry, I know this sucks, and I am the one who opened the issue on the SQL client repo to say, please implement this optimization. That's it. I mean, we still have this principle where we're not going to go and we're basically not going to go and implement it in our level because it doesn't belong there, unfortunately. I think we're good, right?
One question, database first, yeah?
Yeah.
Many customers use database first. Databases was generated by T4 templates, yeah?
Right.
Very old technology. Are you planning change to, for example, Razor syntax maybe?
It's a different type of templating language.